application aware routing. And these are kind of set of, I would say, policies itself that are deployed in order to ensure a better, I would say, business flow there. So when you think about policies, then there are different kind of policies that we have saw, that we have seen. And first type of policy has been centralized policy, and the second type of policy has been localized policies. And the centralized policies, as I said, works on WAN perspective, and localized policies works on LAN perspective. And these are also categorized into control policies and into data policies. And same here as control policies and as data policies. So you can have like a centralized control and centralized data, localized control and localized data. Now, when you think about centralized data policies, then you can say this is like kind of a special type of data policy when we talk about application aware routing policies. So you can consider it as like a special type of data policy which enables organizations or infrastructures, like you can say, to move away from like high cost and guaranteed performance transport, and then like for example benefits that's provided by MPLS.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Right, so when you think about like building an SLA with the ISP, or when you think about getting high bandwidth from an ISP, or when you think about link upgradation when you're from an ISP, all of these kind of services are provided to you, but these are very costly services that are provided if you talk about like corporate network. And these are all services that you will get in like pure MPLS network, if you're just working on the private like private circuit, by building up a private circuit and then communicating between different sites together. So in order to like reduce the cost of the infrastructure being rented out or the infrastructure being used from the ISP, this particular thing, application aware routing, helps a lot there. So for example, you can have all these benefits that is actually provided by, or that are actually provided by MPLS on the public commodity internet circuits as well. So you, and while like not sacrificing the application performance itself. So this policy specifically focuses on application performance. As I told you, like a very basic example of where this would kind of be used, right? I gave you a scenario that you can have VH1 here, and you can have VH2 here, and then you can have multiple type of transports. You can have public internet, you can have another type of transport for MPLS, let's say, and you had another type of transport for, let's say, LTE, and you want to reach out from V1 to V2, you can build a tunnel over public internet as well, over MPLS as well, and over LTE as well. And you can build up policies that actually monitors things like jitter, right? That actually monitors things like delay, that actually monitors things like loss. And based on the like monitoring, it'll the VH1 will actually decide that by using which way the transport actually or the traffic actually needs to be sent. Makes sense? This is kind of a classic example of how application aware routing, or what application aware routing policies does. So all these things are is kind of accomplished by monitoring the characteristics of transport links in real time, and then incorporating that information into like routing process. So this kind of stuff enables network admins to ensure that their applications are always being forwarded down a path that actually meets or kind of exceeds the requirement of that particular application. Because like it can vary from application to application perspective, right? Your data center might be like hosting some application that purely deals in data, right? Your data center might also be hosting something that purely deals in I would say voice, And same goes for video as well. So when all of the characteristics of three different type of data differs from each other, right? Where voice and video are kind of latency sensitive data, and they need to be sent, for example, over UDP. And data, however, like actual data, be it emails and be it files and all these things kind of needs to be or must be sent over TCP, so that if there's any loss, the data can actually be retransmitted there and the successful guarantee can be ensured, right? So like requirements vary from the type of traffic that's going onto the like tunnel. So when you think about like the business like aspect of how this application aware routing is working, you can say that and one of the key like business drivers for many organizations is to move to SD-WAN is the it can, is for the ability or to replace their existing expensive legacy transport networks with higher capacity and less expensive broadband circuits, because SD-WAN kind of gives you the ability to use public internet as well in order to connect your different sites together. So this transition is kind of enabled in part by like SD-WAN's capability to continue to provide an assured application experience over transports without an underlying SLA commitment. Because when you need an SLA commitment, you need to spend more money in building up the connection between your sites by just keeping up with the private circuits that you have. So by moving away from existing legacy transport networks and moving to using the like internet as a transport, many organizations are finding that they are like they can dramatically increase their available bandwidth, while at the same time they can reduce the transport cost as well. Like there's not guaranteed service level or service level agreements onto the internet, because it's just kind of a commodity internet and not a private circuit that you will get kind of an L, or you will be creating an SLA with the ISP or so, right? So many organizations have relied upon their like lease line and MPLS transport providers for like assured level of service. While there's no solution can guarantee an assured level of service over the internet, I would say. But the SD-WAN can like leverage the benefits of low cost internet transports, while at the same time it can utilize the application like something like application aware routing. Um, and packet loss monitoring and jitter monitoring and delay monitoring and all these kind of stuff can actually be used in order to keep your application always up and ready. So using application aware routing, admins also are able to identify the business critical traffic and specify the required service level agreement for that particular traffic class as well. So when replacing or increasing the I would say the existing MPLS transport circuits with internet as a transport, then organizations are kind of able to establish multiple connectivity paths between their, I would say, locations, like whatever locations that they're going to, because it's not really mandatory that your VH1 and VH2 would be located on the same premise, right? It needs to be on various other premises there. You can have high availability over there as well, but you cannot have high availability there as well there. So when replacing, as I said, the ability to move to the internet as a transport, still like while still being able to provide for the required end user experience, enables kind of companies to realize that cost saving by utilizing all of the bandwidth in an like active fashion is pretty much beneficial than using something like active standby, where you can have like redundancy of devices, but it's not really useful when you're just using one of the device as your active and the other one is completely down there. So it's better to use like the scenario of active deployment, where both the devices can actually be you can say providing their services to the network by like working in a manner called active, which will kind of be a part of load balancing or something like that, right? So that's exactly what the benefit of application aware routing would be.